name is Kingsley Wood. I'm with the business development team of Amazon Web Services based here in Singapore. Today's webinar is going to cover the total cost of non-ownership in the cloud. That's our title for the content today, and we'll get started right away. So a lot of you are probably familiar with Amazon Web Services already. I'm sure you're familiar with a lot of our products and services. Just to give you an idea as we lead in here where Amazon stands today in terms of the global marketplace for cloud computing solutions and so on, we've received quite a bit of good feedback and reputation from a lot of analysts. This just gives you some examples of some of the ratings we've received from the 451 group, from Gartner, from Forrester, etc. Many of you will be very familiar with a lot of our customers. We power a lot of the popular internet brands that a lot of people use. If you see companies that you recognize on there like Instagram, Playfish, SmugMug, Zoopla, Pinterest, etc., all have implemented a lot of their solutions, some of them all of their infrastructure, their IT infrastructure, on Amazon Web Services. Of particular note, you'll see companies like Dropbox, which many of you are familiar with, that don't actually own or pay for any of their own infrastructure, but rather use Amazon Web Services to conduct all of their IT back end for them while they provide great services to people around the world. In terms of the enterprises that we've acquired, we have managed to build a very familiar list of very large enterprises. You'll recognize companies there like Samsung and Shell. In particular, note down at the bottom right there, Amazon.com itself runs on Amazon Web Services. So the entire bookseller, DVD seller, and in fact the entire online system that we have powering Amazon's commercial website runs on Amazon Web Services. You'll notice that when you have large brands like NASA, Unilever, etc., trusting their IT infrastructure into Amazon Web Services, that we've really acquired a very high-profile list of enterprises that now trust their IT infrastructure over to us, which is quite a compliment to us. Here in ASEAN, we have a number of very familiar customers that actually have done the same. As we've rolled out our infrastructure in terms of regions, both in Singapore, Japan, and most recently in Sydney, we're able to address the local market in ASEAN. You'll recognize a lot of these companies as well. If I go into a bit of detail now about the global infrastructure, just a brief summary of where we are located. We're now running into our 6th year with Amazon Web Services, and you'll see that we have regions, AWS regions, located in 9 different locations around the world, and edge locations in 35 locations around the world. And I'll get into a little bit of detail about how those interact and work together. I launched Sydney just a few weeks ago, so we now have a complete region down there for Amazon Web Services as well. So before we get into the total cost of non-ownership and all the financial details, I thought it would be a good idea for us to just begin with a brief overview of the components that make up the whole AWS cloud. I've just discussed the global physical infrastructure made up of regions, and within those regions we have multiple availability zones. An availability zone is a distinct data center, and we have multiple availability zones in each region. So for instance, in Singapore here we have 2, A and B. Each data center or availability zone is separated by low latency Amazon proprietary dark fiber. So we have connectivity between them, which enables us to synchronize applications and databases very, very rapidly and reliably between those availability zones. Each availability zone has its own distinct power supply, its own distinct infrastructure and physical building, so that even in the event of a catastrophic failure of one of those availability zones, an application or data that is distributed amongst multiple availability zones is safe and redundant. Now the edge locations, which we mentioned earlier, are facilities around the world that enable us to deploy and distribute the content from your applications closer to the end customer. So if you imagine an application that's based in Singapore, but you have customers sitting in Paris, in Germany, in Sydney, etc., we're able to use the edge location network to send static content to a local cache closer to the customer, so that subsequent requests for the same content doesn't have to go all the way back to the original location or the origin server. In addition, Amazon CloudFront, which is the system that takes advantage of these edge locations, has recently stepped up its game in terms of adding in the ability to distribute dynamic content. So now not only static content like images and video files, CSS files, etc., but also dynamic queries can be cached at the edge location, which saves a lot of the inter-region traffic or inter-availability zone traffic and can make the customer experience for mobile apps and web applications that much more efficient. So building on top of this global physical infrastructure, we have 4 key components to the cloud computing universe that AWS provides. And these are compute, storage, network, and database. And I won't go into a lot of detail about all the services here, but just know that just about any IT infrastructure needs you have is going to be made up into one of these 4 key components. This is what we call our low-level building blocks. Above these building blocks, we have several distinct services that provide functionality and features for typical workloads that you as a customer might be experiencing. I'll draw your attention, for instance, to the messaging, Amazon SES, which is our simple email service. If you're the sort of company that needs to send out thousands or even millions of emails, rather than managing your own email service on servers, we provide a completely fully managed service where you can simply provide the content and we will then send the content through to the customers. So if you look at something like Cloud Search, we're able to index a lot of your content automatically for you. SNS, which is our notification service, SQS, the queuing service, etc. All of these are high-level building blocks building on top of the 4 key components: compute, storage, database, and network. Now, one level above this, we have many cross-service features. Something like IAM, which is our identity and access management, helps to manage the users and the accounts under which you control all of your Amazon Web Services capacity. I'll draw your attention in particular to monitoring. CloudWatch enables you to extract metrics from the operations and the applications that you're running in AWS, and then you can pivot on those metrics and details to actually define thresholds that enable you to take actions. For instance, when a particular set of application servers becomes too busy, you can then fire off an additional set or an additional array of servers to help handle the capacity, and vice versa as well for ramping up and down. And we'll get into that in a little bit more detail in a minute. Of course, all of this makes sense because we're able to access all of Amazon Web Services through a variety of different routes. For instance, there are the SDKs in which we provide the ability to use libraries in most of the well-known languages. We have a web interface, the management console, which lets you manage and monitor all of your application capacity in AWS, as well as plugins to various popular tools like Eclipse and Visual Studio. Amazon Web Services is pretty much agnostic from a platform or language point of view, so you can use anything that you're familiar with. Any languages or platforms, .NET, Java, etc., can all be used to access the services and actually to build your own tools and mobile applications on top of that. And of course, on top of all of these cloud components, which I've just gone through, resides your application. And that's where you can bring your magic, your customer-facing smarts to the service and actually use them to target your end customers. Now, all of this is going to turn into more of a discussion about how much this costs and what you're actually paying for. And the critical thing that we pay for what you're actually using. So in terms of all the costs and expenses, all of our services are based on that pay-as-you-go model. Now, it's of great concern to us that when customers evaluate Amazon Web Services and cloud computing in general, that they don't do a very good job of comparing apples to apples. So it's important to us that you really consider the true cost of running your own infrastructure when comparing to cloud computing, to take into account all of the additional expenses and things that you might be paying for that could sway your decision whether or not the cloud computing option is really beneficial. So what I'm going to do now is go through 5 simple steps that we recommend you do when you're evaluating the total cost of ownership, or as we like to say, the total cost of non-ownership in using the cloud. The first one that we'll deal with here is an ability for you to understand all the different use cases and applications that you're actually considering in your existing infrastructure. If you consider all of your assets that you have running now, you might have a lot of interdependencies between them. There are a lot of applications that you might have built up from legacy acquisitions. There are a lot of databases that you might be relying on, and different applications make different use of those applications and databases. And of course, you can rank them by different sort of categories in terms of whether they're highly confidential information, whether it's information that needs to be shared or not shared with the customer. Also, whether those applications are running very hot in terms of a lot of traffic on a regular basis, or maybe they're very low impact, low utilization applications that really don't have much need to be very high powered, but actually just have to be highly reliable. So what we encourage you to do is really stack rank all of your IT assets and make sure that you're evaluating which ones are really applicable to move into the cloud. We certainly don't advocate that it's an all or nothing proposition, that you have to move all of your applications into the cloud or none of them. We highly recommend that you evaluate which ones make most sense and work with some of the easier applications to migrate first, so that you can get a good feel for the cloud as you move across those different categories. Now, we've spoken to a lot of enterprises, and in the process we've identified that there are really three key usage patterns that we've seen recurring amongst them. The first one is a steady state application. If you think of something that needs to run pretty much the same level of intensity or utilization on a regular basis. Then we have spiky, predictable workloads. Think of these things like payroll that has to be run once a month, or a tax application that runs once a year or once a quarter. And then finally, the third usage pattern, which we'll get into, are uncertain, unpredictable ones. These are the ones like launching a campaign that you don't know is going to be super successful or not. Or maybe you're a game developer or a mobile app developer, and you hope that things are going to be really popular, but they might not be. So you need to make provisions for uncertain or unpredictable traffic behaviors. So really what we encourage you to do is take a look at all your IT assets, identify a certain subset of them, and extract that as a first trial to move into the cloud, and have that as an evaluating basis for you to compare IT infrastructure on your own premises versus in the cloud. So the second thing we're going to look about here is really taking into account all the fixed costs. We find that a lot of customers don't really account for all of the hidden costs that actually go into running IT infrastructure of your own. If you look at a report done by Gartner some years back, they did a very intensive look at all the different things that customers end up paying for that they didn't realize are actually attributed to running an application. It's not simply just a matter of running one box with the application on it. There's a lot of different aspects of it, and connectivity and networking and facilities and so on under the covers that actually need to be in place before that application will run reliably on your on-premises application in your own IT infrastructure. So if you look at these in more detail, you'll see that a lot of them have to do with ongoing expenses. If you look at the details, for instance, in maintaining hardware, network, servers, and so on, all of these are very expensive upfront investments that your company may have made or is planning to make in terms of providing IT infrastructure that you can then run applications on. But once you get into the cloud, you'll realize that a lot of these costs are vastly reduced in terms of the upfront. There is no upfront cost, and it's simply a management of moving it from a CapEx expense to an OpEx expense. Something to consider in this kind of environment is something like hardware administration costs. If you're going through a process of acquiring a whole bunch of hardware, you probably feel the need to evaluate a whole bunch of different vendors, make sure that those vendors are compliant with all of your policies. You're then evaluating a whole bunch of specs. You're going into the details of the maintenance agreements and the delivery and shipment of all that hardware. All of these expenses can be put away when you're dealing with a cloud computing solution, because it's simply a matter of switching on the provision capacity that you need and switching it off when you don't need it. In the same regard, think of the expenses and administrative costs related to running a database. We have found when we've spoken to our enterprise customers that on average, a very competent DBA in a large enterprise can probably handle something like 20 databases under one DBA. In Amazon Web Services, we're able to ramp that up to 400 to 1, given that the automation and the process of actually maintaining those applications is that much simpler when you're dealing with large scale and large amounts of automation in there. So our final message, our takeaway in this section is really don't forget all the hidden costs that go into running IT infrastructure on your own. The third section I want to talk about is really the fact that Amazon Web Services has a continuously evolving pricing schedule. We publish all of our pricing publicly, but you'll see that in the process of growing and becoming larger scale, AWS has been able to reduce our costs significantly over the years, and we pass those savings on to customers automatically. If you think about the massive economies of scale that we're able to look at, all the thousands of customers, we have hundreds and thousands of customers in over 190 countries now. We're able to build infrastructure to consolidate a lot of that usage, and we see a lot of those capacity constraints that a lot of customers have in their smaller environments are much less of an issue for us. So by employing large degrees of automation and monitoring and so on in our systems, we're able to actually handle a lot more volume, a lot more scale than most customers do, and in that way we're able to reduce the costs for each customer. If you look at the details of our actual cost reductions, we've managed to lower costs many, many times in the last 5 years. And the great thing about it is that we pass those savings straight on to the customer without them even having to be aware of it. So every month when we reevaluate a customer's bill, we simply drop the prices and the costs down according to our latest costing structure. Of course, we publish all of our prices online. You can go and look at them on the website. There's no special secret pricing or anything. And the pricing is based on a number of factors. One is the region in which you're using the services. For instance, storage varies across different regions. Data transfer varies as well, depending on the region that you're actually pulling the data out. But you'll also notice that there's a tiered aspect to the pricing. So the more you use, the less you actually pay per amount. And just to summarize our cost structure very simply, in terms of running capacity, those machines are charged on a per hour basis. In terms of storage, we charge on a per gigabyte per month basis. And then finally, the charge of data transfer is based on the amount of data that's actually transferred. In other words, we don't require customers to pre-provision a certain amount of data transfer or traffic. We only charge them when the bits are actually delivered. Think of the use case when you have a 100 meg video file available for your customers. If they only watch the first 10 meg, they're already going to pay for those first 10 meg to be delivered. So that's another great way where we implement our philosophy of pay-as-you-go. Just a bit of a deep dive into this in terms of storage. Imagine if you were a customer that over the next 3 years predicted that you were going to be putting around about 45 terabytes of data into the system, which is an amount of data that seems huge only a few years ago is pretty commonplace now in terms of collecting and aggregating data. If you think about how that data flows into the cloud, over a period of time, if you had your own system that you had to provision enough storage to handle this, you might, even on a step function, implement a amount of provisioning, for instance, 20 terabytes, ramping up to 50 terabytes after 2 years. But you'll notice that there's always going to be a gap between the amount of provisioned storage and the amount of actual storage used. This is the beauty of the cloud, in that you're only paying for the actual amounts of data that's already in the system and not the amount of system data that you think might be needed. So in terms of comparing this to an on-premises solution, you're always going to have underutilization and waste, versus in the cloud, you're always going to have 100% utilization and optimal efficiency. In addition, AWS provides many of our services on a trial basis. You might not know this, but you can pretty much use most of our services for free just by signing up for a new account. In fact, just recently we added RDS into that fold so that you can use RDS, our relational database service, for free just to try it out. So I definitely encourage you to look into that just in terms of evaluating all of AWS's products and services. So now I'm going to get into a little bit more detail about the actual specifics of the economics behind using our reserved pricing versus on-demand pricing. When we talk about servers and capacity in EC2, Elastic Compute Cloud, we have various ways of you actually paying for those services. So think of a server of varying size, and you had a varied number of those servers actually running. There's actually 3 different ways to pay for them. I'm going to go into those in a little bit more detail. You're probably very familiar with our on-demand instances in terms of just paying for them as you go, and that's starting from as little as 2 cents per hour for a micro server, going up to our quadruple extra large with fries and the shake and the whole big deal. So those are massive machines that you can use on a much higher hourly charge, but those can all be made available to you on an on-demand basis. The second way of paying for these EC2 servers is what we call reserved instances. Now this has got two components to it. The first is a one-time low upfront fee, and then this enables you to use the servers on a much lower hourly rate moving forward. And these come in various flavors. We have 1- and 3-year terms, and we also have different utilization models, heavy, medium, and light. Now without getting too complicated, I'll show you a quick break-even graph here, which shows going from left to right, an increase in utilization might mean that you might want to use some of our higher utilization or medium or light utilization reserved instances depending on what's ideal for your customers' needs. If you have a web server that's running 24/7 and will be running for the next 3-year period, it could be that a heavy utilization reserved instance makes the most sense. If you are using something intermittently, for instance, to run reports or to run services and workloads that aren't very frequently repeated, you might find that light utilization or medium utilization reserved instances make more sense. And of course, you have the option of using either 1- or 3-year period RIs to decide which one works best for you. In terms of the sweet spot or break-even point on this, here's a brief summary of the percentages of utilization that might make most sense. You can see that anything that's running more than about 75% of the time, heavy utilization RIs can save you up to 71% over a 3-year period. So let's apply this thinking of reserved instances and capacity arrangement into the 3 usage patterns we talked about earlier. We'll start with the steady state usage pattern. If you think about a number of servers or amount of traffic that's fairly steady state over a long period of time, the one option would be to simply buy the servers yourself, run them on an on-premises infrastructure or colo, but the other option would be to buy reserved instances in AWS. Now I'm going to compare with a bit of an eye chart here, just the whole cost analysis of all the different breakdowns of expenses that you would pay for an on-premises option versus 3 different options within AWS. The option 1 is really the optimal way of using reserved instances. By purchasing 3-year heavy utilization reserved instances, you can see that we can, in this example, realize savings of up to 68%. But you'll see if you look across to option 3 that there's actually a negative result there. And this isn't totally unexpected. What it's basically saying is that if you're paying full price for AWS's EC2 servers, it could work out more expensive than if you were to try and run it yourself. And this isn't really a surprise to us. We're just saying that when you make the comparison, make sure that it's apples to apples. Make sure that you're comparing our best pricing and our most applicable pricing, in this case, all reserved heavy utilization RIs, to actually compare them to your on-premises solution. So make sure that you're looking at the best option within AWS when you're comparing with your on-premises solution. So now I'm going to move on to the second usage pattern, which is a spiky, predictable usage pattern. So consider something like a report system that runs pretty much 24/7 throughout the year, but there's an occasional spike in terms of a monthly report that has to be run or quarterly report. The one option, if you're running on premises, would be to run physical infrastructure to the maximum amount. In this case, you would have to allocate enough capacity to actually cover the complete worst case scenario. In other words, the sort of the high watermark. So in this case, it would be 10 instances running all the time. In moving this to a cloud solution, you have the option of buying a combination of reserved instances and using the rest on demand. So you can consider 4 instances in this case being purchased with reserved instances when you know those are going to be running steady state, but then covering the on-demand or the spiky loads simply by moving them up into on-demand instances that can be switched off when they're no longer needed. This applies basically back to the same philosophy that AWS has: switch them off when you're not using them. So we encourage you to switch off any capacity that you don't need, and in that way reduce your costs so you're only paying for what you actually need at any one time. So putting this back on the chart from the previous example, you'll see that all of the infrastructure costs involved in on-premises options are still there. You still have to pay for the hardware, the power, the cooling, the data center space, etc. But in the options from AWS, you actually have the variability of choosing how many of your capacity or how much of your capacity is actually allocated to reserved instances versus on-demand instances. And in this case, you'll see the optimal solution actually comes in as option 2, when you have a combination, a mix of on-demand and reserved instances. That can yield the most cost-effective solution. Again, the solution of buying everything on demand is not going to be the most optimal. That's the third option there, because you're simply going on a commitment-free and a risk-free option. You can switch them off at any time if the whole application was no longer needed. That's great, but you're not taking advantage of using a mix of reserved instances and on-demand. So now we get to the third usage pattern, where it's really the key issue here is that it's unpredictable. You don't know how successful it's going to be. Of course, we all hope that our applications are going to go high and to the right, and that's the objective of building any large-scale application or website or campaign or mobile app, but we don't always know that it's going to be that successful. So in this case, in this scenario, if you were to buy reserved instances right up to the very top of your predicted traffic, you're probably going to be wasting quite a bit of money. You don't know that it's going to be that successful, so why pay up front when you don't know that you're going to need all that capacity? Instead, if you were to build this in a physical infrastructure, you would have to allocate all of it again to the high watermark, to the worst case scenario. But in terms of the actual results, let's say in this case we had not as successful application, not as successful a rollout, so over a period of time the actual traffic was far below what our expected traffic was. In this case, we really want to be able to take advantage of our light and medium utilization reserved instances, which really just reward you for being able to turn them off when you're not using them. So they might not be as expensive up front, and the hourly rate might not be as good as the heavy utilization reserved instances, but they're certainly much better than the on-demand pricing, so that your hourly rates are less, but it enables you to switch them off when you're not needing them. So in terms of the chart here, you'll see that the factor, the savings versus on-premises solutions, really is a basis, or it's a function of how much you split your application capacity into reserved instances versus on-demand instances. In this case, if you were to have gone fully for an on-demand case, you actually realize the most savings, but that's just because in this case things were not as successful as you'd hoped them to be. But one of the philosophies that we encourage here at Amazon Web Services is to experiment continuously and keep trying things. We believe that our philosophy of using AWS in an experimental way will actually help to increase innovation, because we're doing this by way of lowering the cost of failure. If you can try a whole bunch of different experiments, if you can try and do a whole bunch of A/B testing and trying some new things, you open yourself up to the opportunity of discovering something that works without having to expend a huge amount of money up front just to make those experiments happen. So in this case that we just talked about, if instead of failure we actually had massive amounts of success, your physical infrastructure option would still be constrained by the amount that you'd predicted right at the beginning. But if your success is a runaway success and the actual traffic goes way above, you can see that the ability for you to immediately add on-demand instances to compensate for that and to handle the additional traffic works in your favor. Of course, there's nothing worse than having less capacity than you actually need at any one time. There's no way that you can call a physical vendor and ask them to deliver another 100 servers in the next few hours. But this is certainly a capability that we offer in cloud computing, that you can ramp up the amount of capacity that you need based on a very spiky load, which is up to that point been unpredictable. And there's nothing worse than having to lose business because you simply haven't allocated enough capacity for that. So that covers the first two models of how to buy EC2 or how to buy capacity on AWS. I'm now just going to briefly cover our third option, which is a very exciting innovation called spot instances. And basically this means that you can bid on the price that you are willing to pay for a particular amount of capacity. In terms of the price variation or fluctuations, we publish the results just like a stock price on our website. And you can see how it varies up and down over a period of a month or two. If you think about the price of an on-demand instance and how the spot prices can vary, most of the time the spot prices will actually be below the on-demand price. So a customer willing to bid on an amount that's below the on-demand price will usually get that capacity as it's spare capacity that we're not using for on-demand or reserved instances. We can allocate those to customers in the spot market. Of course, there are occasional times when demand will actually drive the price above the on-demand price, and there are situations where the customer needs to take that into account. The one caveat in terms of using spot prices is that if someone else were to bid a higher amount on the same capacity, we then take that capacity from the first customer and give it to the second customer without warning. So the dedication of using spot prices requires that you actually architect your infrastructure and architect your application in such a way to be able to take account of this variability and availability of the system. There's some very, very good use cases, however, that come out of using spot instances. A lot of jobs and workloads that don't necessarily have to be completed right now, that they can be put off based on the fact that you'd rather pay less for them but have them done later. That sort of thing, like video transferring, processing, a lot of scientific computing, processing and data management, anything that can be put off by a certain amount of time that doesn't have to be done right now and live. Of course, there's some very interesting outcomes from this bidding process. We have customers that are looking at very different bidding strategies in terms of getting this capacity and making it available for them. Most of our customers bid below the on-demand price, and that's able to suitably provide them with capacity, which is not the end of the world if it gets pulled out from under them. However, there are some customers that bid as much, if not just slightly above, the actual on-demand price. And the reasoning here is that even though on occasion they might have to pay the on-demand price, the vast majority of the time they'll actually pay less by covering the bid on a price below the on-demand price. Of course, there's some customers that have gone to an extreme here in terms of bidding at 200% or even as much as 500% of the on-demand price. And again, the thinking there is that they can compensate for the ability for the stock price or the bid price of the instances to actually vary so high on occasion that they're willing to pay those extreme prices in order to maintain control of the instances. Because of course, the higher they bid for those instances, the less likely they'll be taken away from them by someone else outbidding them. A great example of a company taking advantage of this is Vimeo. If you look at their offering at the moment, when you upload a video and you simply take advantage of their free service, they don't give you any set guarantee of when that video will be posted or processed. In fact, what they're doing under the covers is using spot pricing, spot instances, to actually process it in a batch when it suits them at the price that they're willing to pay. If, however, you're willing to pay for the premium price and subscribe to Vimeo, they will then invest in additional RIs and pay for on-demand elasticity using systems and capacity that they are willing to pay for additional to make sure that that work gets done immediately. So that really helps out to differentiate their customers between those that are taking advantage of the free offering and those that are willing to pay the subscription. So all of this is well and good, and we've talked a lot about dollars and cents and how these all apply to the different instances. But the final aspect that I really want you to think about in terms of comparing an IT infrastructure outside of the cloud and inside of the cloud is all the intangible cost savings that you can really take advantage of here. One of the best examples of this is our security model. We have what we call a shared responsibility model. We provide basic infrastructure, security, physical infrastructure, as well as all the necessary certifications and hardware and software and network systems to maintain control of your systems. But bear in mind that if you think about Amazon.com itself running on AWS, you as a customer have immediate access to our premium security at very non-premium prices. One of the things we always encourage large-scale customers to think about is how much of an investment they have made in terms of the security team. For a large enterprise to employ 15 or 30 security experts would be exorbitantly expensive just to run their security systems. But by taking advantage of AWS, all of your customers and all of your infrastructure can then be placed at the same premium security level that we ourselves run Amazon.com on. And if you consider companies like Samsung and Shell and NASA, they have taken endless efforts to make sure that they have vetted our security as adequate. In fact, the federal government of the US runs over 300 of their constituents on AWS and believe in many ways that their security is better now in AWS than it was when it was under their control. So that's quite a compliment to us. So this is just one of these intangibles that you get right off the bat at no additional price by using AWS. A second considerable market value is the value of being able to just move very quickly. The profound agility that you can actually gain by using AWS is quite amazing in terms of getting product to market, being able to tear down and build up new infrastructure stacks very, very quickly, and in the ability for you to try different things, has enabled a lot of our customers to be incredibly agile, taking advantage of AWS. Of course, all of this gets back to the basics of you focusing on your business. Many of you are running companies that don't necessarily focus on being IT infrastructure players. So the ability for you to run your business, focus on what differentiates you in the eyes of your customers is a huge advantage if you can do all that without having to worry about the headaches of running your IT infrastructure. What's fantastic as well about AWS is that you can completely revisit your architecture on a regular basis. If it turns out that your design and your allocation of resources, or even where they're allocated worldwide, has changed in the last few hours or even the last few minutes, you can literally change that capacity and change that infrastructure by shutting down systems and starting them again where you need them. This enables companies to go global very, very quickly and enables them to change the way that they're using AWS on an hour-by-hour basis, which can result in massive savings on their bill. We just talked about a whole bunch of different instance types, but there's also the capacity of being able to use different services to take advantage of, like our database services, our email services, and so on, where you can offload workloads from your existing systems into our managed services. And finally, one of the things we hope we can give you is a good night's sleep. If we can enable you to get rid of a lot of the headaches of IT infrastructure, a lot of the worries and concerns about having reliable backup and database replication and so on, all of those things can simply help you to focus more on your business and run your business better. So again, when we're asking you, what we're asking you here to do is really make sure that you're doing an accurate apples-to-apples comparison when you're comparing all the different aspects of total cost of ownership. So just to summarize again, this is our pricing philosophy. We believe very strongly that all of our services should be priced on a pay-as-you-go model. We're trying to change the way that licensing works, the way that hardware allocation and provisioning works by moving everything into that from the CapEx model into an OpEx model. Of course, we've differentiated our pricing by making sure that it's all tiered and making sure that the more you use and you get rewarded for your volume discounts or volume usage. And we encourage customers to take advantage of our different pricing models like reserved instances, which we've discussed here. And of course, just by being on board with AWS, as we go through the process of building and getting stronger and adding more and more customers, you will reap the benefits of that as you see our pricing change and our pricing drop. Just recently, last week in Vegas, we announced almost a 25% reduction in our storage costs alone, which is quite a surprise to all the attendees and in fact all of our customers worldwide. Not something that they have to opt in for, but something that will just reflect in their next bill. We've recently released a TCO calculator, which is viewable up here. You can go to this URL. It gives you the opportunity to basically describe in terms of your numbers the size of an infrastructure that you think you might need, and it'll give you a report published in a PDF that we'll send to you, which will compare the kind of costs, the typical cost that you would expect to pay on an on-premises solution versus AWS. And if you launch that calculator, I'm sure you'll be pretty surprised at the typical costs that you might not have considered in terms of maintaining a network, making sure that your environment in terms of power and cooling, even from a personnel cost, is quite significant. All of those costs having been eliminated if you could move into the cloud, into AWS. So finally, I'd encourage you all to visit our Economic Center, where we have a lot of PDFs and details. There's some great white papers there which can describe a lot of the content that I've been going through. We have various calculator tools, including this TCO calculator. We also have an estimator, a monthly estimator, where you can describe the sort of capacity that you expect to be using, and we'll give you rough estimates of what that'll cost per month. But again, bear in mind that you can always allocate your costs in terms of a high watermark, a worst case scenario, and as you evolve on the system, you can revisit that architecture and build it down to even less capacity that you need as you become more efficient in using AWS and offloading a lot of your workloads to our different services. All right. If you are using the system right now, we encourage you to ask any additional questions. You can open up the little bar there on the bottom right and actually feed in some questions. We've got a whole bunch of people standing by here to answer your questions. Finally, I'd also encourage you to take a look at our IDC report, which was recently released. I'm going to try and show that quickly here. There you go. So Amazon commissioned a report to be done with 11 large organizations, and it just follows their usage of AWS and usage of cloud computing over a period of a few years and seeing what the potential savings could be made simply by moving to a cloud solution versus an on-premises solution. So we encourage you to take a look at that. So again, if you've got any questions, happy to take those now. If you can fill those in on the forms there, we can get some answers to you. But thank you very much for your attention. We really appreciate your time and look forward to seeing you in the cloud, AWS. Thank you very much. Okay. All right, well, if there are no more questions, we will answer the rest online. And thank you very much for your attendance, and feel free to contact us via aws.amazon.com, and we can follow up. Thank you. So we just got a few questions that have come in now we can try and answer. One question is, can we have the India as a region covered? What do we expect for latency and speed? We don't currently have any infrastructure in India. As you can see from our global infrastructure rollout, we continually add edge locations and regions. We're continually moving around. We don't pre-announce any plans to go into any specific countries. But I've been to India several times this last year and have experienced pretty good latency. One of the factors that I want everyone to consider here is that even though our regions can be very powerful and our AWS systems and services and network can be very good, we still rely on what we call the last mile. So customers still have to get their connectivity from wherever they are, from their office, from their home, from their mobile device, into AWS. And this is not something that we necessarily have any control over. Of course, we try and work closely with the telcos to make sure that the routing is as optimal as possible. But I'm sure you all be familiar with the fact that even within any country, there's going to be various ISPs, various different levels of quality that can help you connect to the internet. So as connectivity improves, as the network improves, this will definitely improve. But at the moment, our edge locations closest to India are Singapore and Hong Kong, and even Japan can service that market in fairly good latency. Another question here is there any information on the risk of the change from on-premises to cloud? We do have some good white papers which indicate some of the best practices in terms of migration. In terms of security or risk to the data that you're working with, we definitely encourage customers to read up on all the security basics and how we arrange our networking infrastructure in terms of the security parameters and security groups and so on. But one thing I'll just add here is that we encourage customers to remember that they can always encrypt their data to whatever extent they want, so that even before it gets into AWS, it can be encrypted to your specific company's policies or specifications, so that the data is actually encrypted when it's in transit and when it's in rest in the cloud. So there's no need to expose yourself to any additional risk like that. However, having said that, we have designed our systems and our security to be as secure as we can by default. So this gets back to my message about it being a shared responsibility model. AWS will provide a default secure system, but it's up to the customer to use it wisely and intelligently and make sure that they understand the risks of exposing or opening up certain ports or changing the security protocols. I've got a question here. Can a CAD application be hosted in AWS? I assume by that you mean computer-aided design. Yes, indeed. We have Autodesk as one of our big customers. They're using AWS to do a lot of the rendering and the calculations behind the scenes for CAD applications. You can certainly look to run all of your applications in the cloud, but depending on the latency, you might not necessarily want to use the user interface aspects of it via the cloud. Of course, you can still use a local CAD application and then simply offload the processing or the storage or the communication and distribution of that content to the cloud, which is quite a good way of taking advantage of that. Question here, do you have any reseller plan? Yes, we do have a reseller plan. Feel free to contact us on details on that. One of the advantages that some customers have that have themselves got many customers is that they can consolidate the pricing and the use of a lot of their customers' usage to actually allow them to offer lower prices, as well as having certain discounts and so on that we offer through the reseller plan. If you can send us more specifics about the details of what your use case is or what you're planning to do, feel free to do that. But we have many customers that provide SaaS services, software, on the cloud based on AWS to multiple customers on maybe a subscription basis. See a question here about backup and restore work. The attendee says we currently have monthly tape backup we keep for 7 years and restore. We need to, in addition to rotating 30 daily tapes each day of the month. We have a fantastic solution for you. We recently announced a new service called Amazon Glacier, and what this is a very low cost but low access service for storage. And what I mean by that is if you need to store something in the cloud in S3, you can definitely store it there for immediate access. But if you have a lot of content that you don't necessarily need to get at very frequently, so for instance your tape backups that you said you just need to keep for 7 years, you can transmit that over to Glacier and it gets as low as a cost of 1 cent per gig per month, which is incredibly low. So you can replace your entire tape and backup system with something far more reliable, far more durable, and actually use that in conjunction with S3. Just a note about this, a lot of customers have concerns about moving large amounts of data into AWS. We provide a service called ImportExport that allows you to actually deliver to us a attached USB drive up to, I think it's 16 gig size. So you can actually, sorry, not 16 terabyte size. So you can actually deliver large volumes to us. We will then ingest that data, make it available in S3, and notify you when it's there. So sometimes it's actually faster to actually ship the physical drive to us rather than trying to transmit huge amounts of data up into the cloud. I see a question on specifics of pricing. Just go to our website, the /economics page, and you can specify exactly how big a size machine or cluster of machines that you want and get pricing on that. Again, a question about migration best practices. We have a lot of white papers available in our white papers section, just aws.amazon.com/whitepapers. And some of those outline very specific workloads like migrating SharePoint implementations up into the cloud. So you can read up on that. Question here about data security. I haven't gone into a lot of detail, but we actually have a very detailed security white paper which I'd encourage you to read. It outlines all the specific policies that we have in place, making sure that our systems are physically secure, and also about the isolation or the segregation of different accounts from each other. So when you have an instance that you run an application on in AWS, you alone are the only one that can actually access those that machine. We at Amazon are not able to access your machine or see what you're even running on your machine. It's simply a matter of you downloading a private public key pair, and then you get root level access to that instance or instances that you want to control. In In terms of accessing from India, yes, you can access it right now. It's simply a matter of aws.amazon.com. There's no restriction on any country accessing AWS. When you do access it, we require three things for you to set up an email, for you to set up an account. We require an email address, we'll need a credit card, and we'll need a phone number. We need a credit card, of course, so that we can charge you, but the first allocation of usage, for instance, your first micro machine and the first 5 gigabytes of storage and so on are all free. So you can actually try out the services pretty effectively without having to spend any money. The phone number is required for validation of your account. What happens when you set up your account is we will actually call you back to verify that you're a legitimate customer, and that'll activate your account. We do not provide web hosting services specifically. You can, of course, mount your website on AWS anytime you want, but we don't actually provide the services of actually configuring your website. There are many, many options that take advantage of how easy it is to run things like Joomla or Drupal or those kind of web hosting services on EC2. So it's simply a matter of installing it yourself. If you're, for instance, a WordPress user, you can Google how easy it is to actually go into AWS, spin up an EC2 instance, install WordPress on it, and be up and running in less than an hour. And again, your first instance, your first micro instance is free for a year, so you can probably provide enough infrastructure for you to run a very basic website with quite a bit of traffic for free for a year just to try it out. So we encourage you to take a look at that. I've got a question here. How do we enforce interoperability between us and other cloud providers to achieve a seamless inter-cloud migration? We have no lock-in and no specific reason why you can't extract your data at any time. So using AWS, we expose all of our APIs publicly. You can take advantage of those to access all of our services and move data in and out of the cloud. If you choose to copy it to other cloud providers or other service providers, or even make replicas to your own on-premises solution, there's nothing stopping you there. And again, there's no lock-in, there's no long-term contracts in terms of AWS. So if you choose to move to another cloud provider, you can simply shut down your applications and delete your content and be out of there right away. So we encourage customers to use our services, obviously in a very flexible way, but there's no reason why you can't extract your data at any time and copy it in as well. A question here about running Microsoft Dynamics on AWS. I'd encourage you to look at our marketplace. This is a facility we've added recently that enables vendors, lots of ISV vendors, including Microsoft and IBM and Oracle and so on, to put all of their software products available on AWS for use on an hourly basis. This is a major shift in terms of the licensing from previous years. If you think about having to pay for a 1 or 2 or 3 year license for some of these major software applications and then realize that you don't actually need them as much, that can be quite a frustrating CapEx expense. The way we approach this with Microsoft is to make all of these software packages available on literally an hourly basis, so that part of that hourly cost goes to the actual infrastructure running the capacity in EC2, and part of that hourly cost is a very small incremental software licensing fee. This is why you'll see running an EC2 instance based on Linux is slightly less expensive than running an EC2 instance based on Windows, because we have to pay the additional small fee to enable the licensing of the Windows platform. So again, if you're after any specific application, go have a look at aws.amazon.com/marketplace, and you can see the tremendous array of ISVs that have provided infrastructure and images ready to go on AWS. A question here, we have 4 terabytes of file server data. Could it be manageable on the cloud? Absolutely, no problem. You can move all that content into S3 very quickly, as I've described on a physical hard drive, or you can simply upload it. But once it's there, it's available as you choose. You can make it available to everyone if it's something that's publicly available, and you'll only pay for the amount of bits that actually get distributed over the network, or you can constrain the availability to a very small subset of users, or make it available through a EC2 instance by installing your own validation or encryption or a system to verify who the users are who have access to it. I've got a question here. What are the limitations of a demo account? Maybe we could try and take a look at that. Let me try and move this up here. If I can bring this up. Is everyone seeing that? Yeah. I'm just going to try and show that screen up there. Is that good? So what I've got here is if you go to aws.amazon.com/free, you'll see all the details of our free tier. Below there, you'll see that EC2 comes with 750 hours of a micro instance, 30 gigabytes of EBS storage, 5 gigabytes of S3, and quite a bit of data transfer as well. And as I mentioned during the talk as well, we've recently added relational database service, RDS, with 750 hours of free micro DB instance running there, which can be running MySQL, Oracle, or SQL Server. In terms of the data transfer, you'll see where I'm highlighting right now, the ability to use 15 gigabytes of bandwidth out, which is pretty tremendous in terms of running a small website. You should have no problems being well below the demo account limit there. Just looking for question here. Shall I use AWS for biological data analysis? Absolutely. We have many solutions running on AWS that use this use case. Biogenetics, bioinformatics. We have large companies like Novartis and Eli Lilly. All these companies using our tremendous amount of compute power to do rapid short-term calculations or workloads and then shutting it down when they don't need it. Again, saving massively on having to invest in all that infrastructure up front. You can simply spin up what you need and shut it down when you're done with it. In terms of tutorials, there's a lot of getting started guides online. If you go to any one of the services like EC2 or S3, you'll notice that we immediately take you to a getting started guide. So if I go to EC2 here on the website, you see it under here. There's a whole bunch of systems in place. That's the marketplace I was talking about earlier before. But if you click on resources, there's a lot of getting started guides and where is that? Oh, can't see it. Maybe there's a getting started guide somewhere else. Documentation. Good call. Yep, thank you. So under the documentation section, you'll see that there's a getting started guide which can guide you through the initial steps of actually using AWS. There's also a tremendous user community out there. We've got, with these hundreds and thousands of customers, many enthusiasts have written forum posts, blog posts, instructional videos on YouTube. We encourage you to just search around. You'll find a tremendous array of data there and instruction that can help you to actually get started with AWS. Our question here is, how secure is cloud storage? Well, let me answer that in two ways. One aspect of security is durability. In other words, how sure am I that we won't lose the data? Well, we have a unique proposition for you. We claim that our durability on S3 is actually 11 nines of durability. That's 99.9999, etc. What we are saying there in terms of real numbers is that if you were to store 1 million objects in AWS's S3 in our storage, and you were to wait around for 100,000 years, there's a minor chance that you might lose one. So that's the kind of volume and numbers that we're actually talking about here. And I'm sure none of us is going to be lucky enough to be around for 100,000 years, and very few of us have 1 million objects to store. So that gives you some idea of the kind of durability. In terms of the security, from a security aspect of someone getting access to your data, yes, the account is very secure from a point of view of you, by default, are the only one that has access to it. If you choose to expose your data stored, you can certainly realize that the risks are there that someone might gain access to it. But again, if it's information that's publicly available, like a video or a JPEG or something, that's not a problem. If it's very confidential data, we again encourage you to encrypt it as much as you like, so that you can encrypt that data before you even bring it to the cloud. So once it's in the cloud, it's as secure as you've chosen to make it from an encryption point of view. So I think with that we'll close up, and we'll thank you again for your time in attending. If there are any additional questions, please feel free to send them to myself and my team, and we look forward to hearing you. Thank you very much. Thanks, bye.